Hi guys. So today I'll be having you make corrections to the assignment from yesterday. So if you haven't done so already, go ahead and open up the assignment from yesterday that I returned to you. And even if you didn't make any mistakes, I still want you to closely watch this video just so that you can get a review of how to do these specific heat problems. They're really important and you'll see them again on a test. All right, so this worksheet starts off with giving you the formula for using specific heat to determine the amount of energy that is required to either raise the temperature of something or to lower the temperature of something. All right, so you can use the specific heat of a certain material, multiply it by that material's mass, and then multiply those numbers by the temperature change that was caused. Either if the temperature went up or the temperature went down, you take the difference and you have a temperature change there. So this whole equation, again, will allow you to determine how much energy is put into a system or how much energy is taken away in order to heat up or to cool something down. We're talking about heat energy. All right? So the very first question is, how much energy is needed to increase the temperature of 755 kilograms of iron from 283 Kelvin to 403 Kelvin? The specific heat of iron is 449 joules over kilograms times Kelvin. All right? So we know that energy equals specific heat times energy equals specific heat times mass times temp change. Okay? And we're given all of this information in the problem. We just don't know what energy is. All right? It says how much energy, so that's a question mark. We don't know what that is. All right? But we do know the specific heat of the metal. The metal is iron, and the specific heat is 449. So 449 joules divided by kilograms times Kelvin. All right, so that's the unit for specific heat. Remember, specific heat is the amount of energy that's required to raise 1 kilogram of substance by 1 Kelvin. So that's why the units are written out that way. It's joules divided by kilograms times Kelvin. All right, now we're going to multiply it by the mass of the metal that's being heated up. So the metal is iron. The mass of the iron is 0.55 kg. So multiply this by 0.755, sorry, 0.755 kg, okay? And then multiply all of this by the temperature change, all right? So the temperature went from being at 283 Kelvin to 403 Kelvin. So to find the temperature change, you take the larger temperature minus the smaller temperature. So you do 403 K, I'm going to put this in brackets, 403 K minus 283 K. Okay? So that will get you, so question mark equals 449 joules over kg times K times 0.755 kg times 403 minus 283 is 120. This is 120, so we have 120 Kelvin, and you use capital K to represent Kelvin. All right, so now we just have to multiply these numbers to get our answer. All right, so you do 449 times 0.755 times 120. All right, and you get 40,679.4. So this is no longer a question. We know now that our answer is 40,679.4. Okay? So, what are the units for this? Well, all you have to do is cancel out the labelings for each of these. In other words, the units for each of these. So, cancel out the kilograms, cancel out the kelvins, and you're left with joules. So the answer is 4,679.4 joules. Okay? That's how much energy is needed to increase the temperature of this amount of iron by that much. Okay? That's how much energy is needed. Now let's take a look at the next one. How much energy must a refrigerator absorb from 0.225 kilograms of water to decrease the temperature of the water from 308.15 Kelvin to 278.15 Kelvin? The specific heat of water is 4,186 joules over kilograms times Kelvin. All right? So in this case, the temperature is going down, and we want to know how much energy, how much heat energy does the refrigerator have to absorb in order to decrease this temperature. Okay? So, let's take a look. We know our formula is energy equals specific heat times mass times temperature change. I'm not going to go as step by step as I did with this first one, because you saw what each step looks like. I'll be a little faster this time. So we have energy equals, we know what the specific heat is because we've been given it. It's 4,186. So equals 4,186, and that's joules over kgK times the mass of this substance. All right, this substance is water, so 0.225. In this case, we have 0.225 kilograms of water. All right, and then we multiply that by the temperature change. Remember, it's energy equals specific heat times mass times temperature change. And remember to always do the large temp minus the smaller temp to get your temperature change. So that means that we have 308.15 minus 278.15. All right, 308.15 K minus 278.15 K. Okay, so 308.15 K minus 278.15 K equals 30 K. All right, so we're going to do 4,186 times 0.225 times 30. And when you do that, you get energy equivalent to 28,255.5. And remember that the unit is joules. We're talking about energy, so the unit is going to be in joules. All right? So it takes 28,255.5 joules of energy to allow the water in the refrigerator to decrease. The water temperature in the refrigerator to decrease by that amount. Okay? That's how much energy it takes. Alright, so number 3. How much energy is needed to increase the temperature of a 0.55 kilogram piece of copper that is heated from 297.15 Kelvin to 318.15 Kelvin? the specific heat of copper is 385 joules over kilograms times Kelvin. So in this case, you do energy equals, remember it's energy equals specific heat. We're given the specific heat here is 385, so 385 joules over kg, that little dot represents multiplication, times the mass. Coming up next, we have mass energy equals specific heat times mass. So energy equals specific heat times mass. In this case, the mass is 0.55 kg, 55 kg, times temperature change. All right, so for temperature change, remember you always take the larger number minus the smaller number. So 318.15 minus 297.15 is 21 K. 21 K. That's 21 Kelvin. All right, so we get rid of our units here, and we're left with joules. All right, so 385 times 0.55 times 21. That means energy equals 4,446. So 4,446.75 joules. All right. So it takes 4,446.75 joules of energy to increase the temperature of that amount of copper by 21 Kelvin. All right. So that's how you do these problems. I think the biggest difficulty that people were having was with the subtraction. Remember, it doesn't matter if the temperature is increasing or decreasing. For change in temp, you just want to find the difference between the higher temp and the lower temp, all right? So you start out with the larger number, and from it you subtract the smaller number. So 43 minus 280, or 403 minus 283, 308.15 minus 278.15, that's the larger number. And then here 318.15 minus 297.15, and that's what I got 21K from. All right, so that's how you do these problems. Make sure you've answered them correctly. And then I think after you make your corrections, you resubmit it to me. I think that's how it works on Google Classroom. So go ahead and do that.